So question 18 is actually I just went through this with my Sec 3 this morning as well. So I will always tell them when you look at a speed time graph, remember to write out the feature. The feature will be the gradient representing acceleration. Another feature will be the area under graph representing the distance traveled. And this is the feature that you are going to use to translate to this part. So we are going to use the area under graph to translate. Okay, so first of all, before you translate, right? So I'm going to find the deceleration first. So the deceleration is like the gradient. So the deceleration in the first 3 seconds, so it's like the gradient. So that's what I did. And I find out that this is the amount of deceleration. So this is the 7 here, and then this is the 3. So that is the deceleration part. And then for part B, right, I think some of you misinterpret. Some of you misinterpret the distance. This distance is the total distance. The total distance is here. It's everything here. I think some of you only do out the triangle. So everything here is going to be 63. Chatina, later I explain to you. Chatina also got something to mention about your drawing. Can see why your arc is so close. Okay, so later on I'll explain. So I think some of you for this part, you misinterpret the 63 as a triangle, but it's actually the whole thing. So you actually got to break it up. Break out into a trapezium. If you don't like to break out into a trapezium, you can break out into a rectangle, a triangle, and then subsequently another rectangle again, another triangle again. So some of you got the part B wrong because you misinterpret the area. So if you have gotten the correct area, I think that's not an issue. So it's the whole thing that is 63. So usually I will go about calculating part by part. So in the first 3 seconds, I will calculate this to be 25.5. Then the rectangle is a 20. And then the last part is 17.5. Okay, so if you want to, you can do out a 17.5 and then use area of triangle as well. It will work. Okay, so before I go to part 3, right? Before I go to part C, maybe since I'm already at the area part, I will do the conversion first. Okay, so you will need to convert this to the distance. So I'm going to teach you how to convert. Okay, so by 3 seconds, think about it this way, huh? By 3 seconds, the distance is 25.5. Do you realize? Because the area is 25.5, the distance is 25.5. So that becomes a coordinate. So that becomes a coordinate. And here is my coordinate. 3, 25.5. So can you see I gotten one coordinate? I'm going to get another coordinate here. This part. By 7 seconds, I will have traveled everything here. The distance will be 25.5 plus 20. That's how I get my second coordinate. So that's how I get my second coordinate here. And then by 14 seconds, I already traveled a distance of 63. So I got another coordinates here. If you go by this idea, right, your distance time graph cannot be like this, cannot come back. There is no such thing as your distance time graph will reduce because we keep increasing our distance. Okay, unless we talk about coming back from another location. So otherwise, if you keep looking at this, right, the distance will keep on increasing. So your distance time graph will keep on increasing. And then you should explore increasing or decreasing. So this part is decreasing. So the curvature will be like this. This part is a constant. The curvature will be a straight line. And this part, again, is a decreasing. So again, it's the same curvature. Okay, so you look back here. Can you see this is the decreasing curvature? This is another decreasing curvature. And this is the constant curvature. So if you observe what I have done, right, what I did was I get the coordinates. I get the coordinates by thinking about the distance. And then I join them up with the idea of decreasing, constant, or increasing. Okay, so this part you need to digest. So this is the one that I'll be letting you practice. Okay, this is one of the weak one across most people. They find it very difficult to translate to distant time graph. Another one that is difficult will be on part C. Okay, I'm going to erase first. I'm just going to do the explanation first. Okay, if you're still not very sure about this, right? Okay, later on, okay, I will be converting the video on so you can re-watch it if you need to. So the steps will be you get the coordinates first. So generally, do you realize just now? I gotten the coordinates and then I join them up with the curvature. So as a simple steps, get the coordinates and then you join them up with the curvature. So this is another one where some people didn't know how to do. We need to find a particular speed. Those who take physics, I think there is a way to calculate, but I'm very bad at physics, so I don't rely on that. So this is the X that I'm interested. So what I did was, right, I did a similar triangle. I got a small triangle here. Can you take a look that the small triangle is X minus 5 and a 0.5. So I got a tiny triangle. And then I can have a big triangle. So the big triangle is 3 and 7. So I'm using similar triangle. I look up for tiny triangle. I look up for big triangle. Basically, it's a gradient idea. But if you want to think of it, you can also think of similar triangle. Then you compare the ratio. You compare this ratio with this ratio. Or you can compare the height ratio with the base ratio. You will still get the same answer. Okay, so this one is again the same idea of increasing rates, decreasing rates, and constant rates.